I would like to introduce Avi Friedman, who will be presenting Open Edge Network Telemetry Tools. Avi is the co-founder and CEO of network observability company Kentik. Avi started BGP's first ISP known as NetAccess and also worked at AboveNet, Akamai, and Server Central. Avi has been a regular attendee and contributor since he first attended NANOG 5 in 1995. Welcome back to NANOG. Pleasure to have you back.
Thank you. Thank you, Alex. I love your NPR voice. It was very good. I am wearing pants and shoes and closed-toed shoes. Something about code of conduct says you need to wear enough clothing. So, I'm going to talk today about some open source work that we're doing at Kentik, trying to solve some problems that we've heard from customers about taking telemetry from all over their network of lots of different types and sending it to the different systems that they have to do analytics, operations, planning, security. To just frame the problem, network, what does that mean? Is it my routers and switches? Is it the internet? Is it the cloud? Is it SaaS? Today it's sort of all of that, and the kind of telemetry you get from it, even if you just say, I want to look at my traffic, it could be from a server, sitting in someone else's facility. It could be, again, routers and switches. It could be VPC flow. It could be something up at the higher level. So there's a lot of hybrid kinds of networks. And we live in a world also where everything is orchestrated. So what was one IP address at one point might not have been at another. So in fact, the metadata about what applications, what users, what groups are running on things is also a kind of telemetry that we need to make sense of things. Different vendors have different implementations, but sometimes even the same box that you get may give you different meaning between SNMP, streaming telemetry, CLI, API. Putting it all together is a challenge. This is the world that we come from, so we've seen a lot of this pain over time from our own customers. And ultimately, the goal that people are trying to get to is answering questions. So to answer those questions, they need to get data from lots of different types of networks and lots of different types of telemetry. Metrics, traffic, config, and really, ultimately, some of the other levels of the stack, too. So how do you put all that together is an interesting challenge. We haven't seen any of the major vendors addressing, and there doesn't seem to be any single open source project that's worked to put all this together. It's something that we looked at and said that we thought it would make our life easier, our customers' life easier, if we actually took some of the technology we had developed between agents and moving network telemetry and develop it in the open with partners and with customers. So we set up something called Kentik Labs and said, as a strategy, we're going to put all of the agents, all the things that sort of do the ingest layer of taking telemetry from the network and put those as open projects. There's also a secondary effort, which is to give people, especially on the maybe our peers who do observability for the application layer or in security, basic tools that they can use to bring networking into their other platforms. Because if you look at querying by prefix or path, these are things that don't really work so well in time series databases. So how do you take the data, reform it, put it into other systems so that it can be correlated? The things I'm going to focus on in this talk are something we built called ktranslate, which actually takes network data, translates it, replicates it, enriches it, does a bunch of things. It also can take NetFlow and SFlow itself, and SNMP. Some agents that we've built that are more for running on servers where you may not have access to the underlying network layer. It may be in cloud, it may be dedicated hosting. So we have some PCAP and ebpf options. I'm not going to go deep into ebpf, but it is a pretty lightweight way of getting data from many levels from the kernel that also can give you performance laden information that you really can't get from most big routers and switches that folks in the NANOG community use. There's some other projects which you're welcome to take a look at, ask questions about. If you go to Kentik Labs, some things around Kubernetes performance with a synthetics agent, which we open sourced. pulling cloud metadata so you can make sense of what VPC and your IPs are mapped to, some flow visibility for people looking to have a low-end solution there, and again, some performance testing. So our goal with the agents and the translator, the reason why we see them together is to really be able to have one platform that you can send all your telemetry into and send it out to the multiple systems that you need. Again, it was something we had to get into. We didn't see any great solutions. When we started, and I'll cover this on a later slide, there was Samplicator for UDP, but that doesn't really handle encryption, so we needed to go do something that did encryption. And by the time you're done, you have a lot of people re-implementing a lot of the same things over and over again. A lot of the streaming telemetry tools are pretty cool, but often live in GNMI and OpenConfig land, and then sort of leaves the SNMP people behind. And of course, Flow was never in the religion of the streaming telemetry side, so much less BGP and other things, BMP and other things. So it's really a broader set than a lot of single point solutions have solved. And so our goal is to make it really work with everything, and on the output side, go not only to network tools, but to other platforms as well. So I'll quickly talk about some of the agents, and where we do see some of this come back closer to the network infrastructure is actually DNS servers. Again, this is one of the reasons why we got into agents, was to be able to do decodes. And so our PCAP agent that we've open sourced, kprobe, kprobe is written in Go. It can do decoding, or it can do kernel level packet sampling. So if you have a server that's running 10 gigabits, you wouldn't do decoding HTTPS and DNS and things like that. But Google introduced some code 5+ years ago to do kernel level packet sampling, so you didn't have to consume all the PCAP. And you can use PCAP to do 10+ gig monitoring with kprobe, or at a lower speed, again, typically DNS server, you can do the decodes, get that out if that's operationally useful. We really are focusing more of our work on ebpf. This has been pretty stable, run in production. Right now it sends data in a cap and proto based format that we use, but paired with ktranslate, you can send it to Elastic, Prometheus, Influx, Kentik, New Relic, Datadog, CSV in S3, Kafka, wherever you wanted to send it. ebpf is the direction that most of the folks in the application world are going. It's, well, how many people have written BPF filters by hand? Yes. So it's that, but for the kernel. So it's really a programmability layer. And you can attach to TCP events, you can attach to packet events, you can really go at whatever layer you want. Doing decodes is, you still have to use a lot of CPU, but if you're really just looking at performance and traffic, or again, in other areas, disk or CPU or other activity, it can be a great way to get data from the kernel. We have 2 agents, one of which is already open source, called Conviz. That's actually pretty minimalistic and designed for people that want to take a look at BPF and how it works. And then Kappa, which has some more advanced functionality, which we'll be open sourcing. One of the things that I'll point out this lets you do, again, is with very low CPU overhead, get traffic annotated with latency. Data that otherwise you have to do synthetic probes to get, or use really specialized lower end enterprise routers and switches that can do that kind of decoding. Again, with ktranslate, you can go to your peers who may run that compute infrastructure and say, hey, if you install this agent, not only do we get it from the network layer, but we can also send it into the other observability systems. So the main meat of what we've been developing towards, and you heard me mention something that helps the agents become more useful outside of just the network layer, is something that we started with called ktranslate. And we started with this really because our customers said, hey, how can we take all the data that you're collecting and enriching and send it to other systems? And so we built something that took data from the network layer in, and let's go back a slide here. Took data from the network layer in and could send it to other data systems. And then over time, we evolved it by saying, how can we take data not just from Kentik, how can we actually do transformations, especially as we started partnering with observability players where people wanted to put something in Prometheus or Influx where you really can't put full cardinality IP addresses and things like that in those time series databases where they have problems. So just a little bit about the history and more about the motivation. When we started in 2014, state of the art for about probably 10 years, I don't know, I think Samplicator was early 2000s, was for the flow side, you could replicate UDP so that if you had multiple tools looking at it, you didn't have to have the router do that at the CPU or the line card if it could do that. Most of the other layers, like SNMP, didn't really have anything. Streaming telemetry was sort of just emerging, but still we see, especially in the enterprise, is not the main way that people are doing network metrics. BGP has BMP and BGP ad paths and different ways of doing things. And what we've seen recently is a trend as an intention that we're going to put all our telemetry on Kafka, usually across the enterprise and also within network operations. But that still leaves you a bit of a problem because, yes, I could use from the Influx suite, I could use Telegraph and write some adapters, and then my adapters will be different than everyone else's adapters. I might hard code logic about how this SNMP or that streaming telemetry thing goes. But the output side, you still have to do your own development. You still have to figure out how to connect that to the different tools and systems that you want. So we really decided, having looked at what we started with ktranslate and looked at what's also going on in the broader observability space, let's actually build towards something which is a single platform, open source, that can take data in from many different types of network telemetry, replicate it to the different systems, enrich it by adding things like, whether it's IPGeo, threat feeds, BGP, CMDB, IPAM, Netbox, things like that. Filter it, and this is where we see filtering and transforming has mostly been either to send summaries into very expensive systems where you wouldn't want to have full resolution like Splunk or Elk, or systems like time series databases, which again, if you put IP and port combinations for the internet in, they're not really designed for that level of granularity. And then operable and scalable. When we started building it, we didn't have all the telemetry, we didn't make it auto-scale, and in fact, it's still not in this state with the project, as I would still like to invite you to try it and give us feedback, but this is where we really want to go. So again, ktranslate, we started working with customers that we had, really taking data from Kentik, and then we did partnership. Our main one is with New Relic, where we got into folks that are network teams looking to replace legacy systems, or even folks that really weren't primarily network teams that were looking to take network data and put it back into New Relic, either as events, which is more like logs, or more commonly as time series data, which again needs roll-ups, sometimes needs filtering, maybe you don't care about ICMP. Where it is today is it'll take SFlow, NetFlow, IPFix, it'll take SNMP, pretty soon it'll take VPC flow logs. We have a Captain Proto-based format called Kflow, and you could think of as the input side. I'll show you in a roadmap. We're going to continue to add different kinds of inputs, both network types and even things like events and metrics more generally on the observability side. Once we get the data into ktranslate, you can say, I don't want things that match these filters. You can chop columns off. You can do roll-ups. Think of it if you're a database person as a streaming query that you're establishing over the data that has these characteristics. I'm filtering. I'm chopping it every so often and sending it off, and put it in. You could even put it in. Anyone still running MRTG in the audience? Cacti. Okay, one MRTG. We got an MRTG here. Hopefully the modified one that puts the new data at the end, not the beginning, but yes. And then output goes to, it's cut off here, but again, lots of generic, lots of open source options, so Influx and Elastic and Prometheus goes into commercial systems like Kentik and New Relic and Dynatrace, and we just into Kafka, and we also can transform it between some of these binary formats and JSON or CSV. Now, right now, a lot of this config is more CLI options. We have some YAML. It is a single binary that you can run in cluster. Where we're going with this is to extend the functionality and actually make it even more operable so that it can really be deployed at the edge. It can roll up some things if you don't need the full level of detail. It can copy things if you do want the full level of detail. Some examples, we distribute it. You can get the source, but we also have Docker containers so that you can run. So you can, send the data to Prometheus, just, fully down at the bottom. You can actually do roll-ups. You can pick some dimensions to roll up on. You could add a filter, decide the output format. So this is functionality that it already supports today, and you can just Docker get, Docker run this. The agents themselves also are distributed Dockerable. And ultimately, where we're going is, the goal is to have lots of different sources, both network, and we're building it so that it can take non-network, all the way up into, think of it as more generically logs and traces. But of course, we want to see syslog from network layer devices and think of them as events and try to correlate and all that fancy AIOps goodness that everyone is working towards. And then in the middle, make it all the same. So that's in the metrics world, the why is it so hard to take SNMP and streaming telemetry and CLIs and APIs, or, and reason about it, make it the same. Add context, again, netbox, IPGeo, routing, change it up and send it to multiple systems. So our goal through this presentation is for people that are trying to do things in this ETL pattern. We'd love to engage and get your feedback. With it, just a couple examples. Same data in, you can send it to Grafana, you can send it to New Relic, again, usually more in time series format. Of course, it works with Kentic. We're fully happy to make it work with really just about anything. So the goal is not to have it be a walled garden, but to have it work with pretty broadly. It's on GitHub. We have the Kentic knowledge base also shows how some of the functionality works, and we have a Discord. So we'd like to invite everyone in. A little bit about the roadmap. What we have on our plate for the next, say, 6 months is streaming telemetry, which I think is technically in ktranslate, but really doing some validation of that. I saw some interesting open source stuff that I hadn't actually heard of before from the hackathon that we need to check out in terms of scraping CLI, which is something that we still hear our customers needing to do to get optic information or other debug metrics, even from relatively recent OSs. Events, logs, and really building it generically so that it can handle more than just the network-specific metrics as well. So in terms of destinations, we're thinking a lot about, on the output side, how do we send reflected as streaming telemetry, GNMI. That might be something that we work with other projects on or build in natively. And then a request that we've had that we're really thinking hard about is how could we do more like what Panoptes is, what Verizon built, Yahoo built with Panoptes, which is putting SNMP on a bus. Like we'll have it in the middle, but how would you have tools that are used to looking at things as SNMP, query something that's either a streaming database or something in the middle. Enrichments right now, we've hard-coded things like BGP, RGNAS or IPGeo, but really making that something that is more generic. Probably won't be at maximum scale up into the tens of millions or billions, because this is going to be something that's designed to be run at the edge, but at least flexible CSV type mappings. In terms of the formats right now, the output side has been a little bit more into other observability platforms. So thinking about any missing network formats that we have. Operability, building in more telemetry, having a Kubernetes native pattern, looking at the ways that people actually want to run it to scale. Right now, it is a single standalone binary, and you would cluster it by itself. We have some folks using it where they're dealing with millions of events per second, so more than even a 64-core server can run. So it is multi-threaded. It is Go makes that, my personal religious belief, sometimes too easy to do, but there's still a limit to what it can do. So those are some of the areas that we're working on. And then as a use case we want to emerge, one subset that we've seen is really combining device metrics. I've mentioned it a few times. Really, there's the same data sitting underneath coming from the device via multiple methods, SNMP, streaming telemetry, CLI API. And the piece that's been missing here that we're looking to generalize is actually the translation of the semantics. So where you may have devices in an enterprise that think about things as the total size of the port and then the percent utilization, and then from that you need to figure out bits per second. How do you do that? How do you do that kind of transformation? Again, with panoptes, that's in the code for the device, which you can override as a class or with an OS version. In Telegraph, you would write that by yourself. So we're thinking, what's the best way to encode that, and in a way that lets us build a community up without us having to be the debuggers of everything, right? And figure out every OS version for everyone, because this is just one source of key network telemetry. So for people that are looking at this problem and some of the systems that we've looked at, there are some other projects. One of them I think was in the hackathon, the GNMI gateway, Panoptes I mentioned a few times, which I'm not up on it. I think it's still more SNMP focused than, it's SNMP streaming it on a bus versus more streaming telemetry. Jeremy talked about something he did for optics, where he was doing more transformation built into it. Cisco has something which I think was renamed from Big Muddy as just pipeline. Those are some of the things that we look at. And our goal ultimately at the end is to make something that works for all your devices, whether they're never going to change. Can I say never going to support IPv6? I don't think I'm allowed to say that. Legacy things that you can't run, or whether you're running a greenfield network and you get to specify what you want. So those are some of the things that we're working on, and would love to get some community engagement. I will go back to the slide if I can. Maybe I can't. But if you check out Kentic Labs and check us out on GitHub and Discord, and if there are any questions right now or remotely.
Remote. And there are no remote questions yet.
Okay.
Is there anybody in the house with questions? Yes. Please approach the microphone. Please state your name and corporate affiliation.
Hello, Avi. This is Michael Costello from Netflix.
I thought that was you.
Hi. I'm wondering why you are choosing a universal format or recreating a universal format as opposed to using something like OpenConfig.
So we think broadly about people that run in the legacy environment. So I don't have any problem with OpenConfig and GNMI as intermediate things, but we also think about people outside the network world, where I don't really see those formats making it into CNCF and people thinking about observability more broadly. So we're actually hoping that the translation layer we're building can help make a lingua franca to take that as input and send it to other systems. This is something we've talked about in the past, is if your only output format is that, then what are you missing? And again, for a lot of the folks that we're working with, we'd love Kentic to be the only platform that they have, but that's not realistic either. So they need to send this data to systems that either don't understand network or don't understand, we'll just say, modern standard network transport methods.
The follow-up is if you're building that lingua franca that's going to transform from n inputs to m outputs, if that translation layer, why reinvent the wheel? Why not make that the OpenConfig piece? I definitely get that you want to.
I see. So you're talking about just for the transformation layer?
Yes.
That's a good question. We're sitting down and designing it right now.
Oh, okay.
So that could be internally, and in fact, I don't see any reason for us to go rebuild GNMI gateway if we can link to that. Or again, I forget the name of it, but it looked like there were some pretty cool scraping tools that I hadn't seen before that were at the hackathon. It's like, well, I mean, the good thing about community is you can work with other folks in the community. So
Yeah, the hackathon stuff, we had Carl, who works on Scrapply and Scrapply Go.
yeah, that looked pretty cool. So I look forward to taking a look at that. But yeah, just to summarize, OpenConfig for doing transformations on network things may well be, the sensible thing to do. But it also needs some, I'll say, community, check, because a lot of the folks that we're targeting with this as an open effort are not, in the OpenConfig world yet. So, but that doesn't mean you couldn't have YAML rules that transcompile to it. So, yeah.
Great. Thank you, Avi.
Thanks.
We do have one from the outside ether,
Okay.
from Blake Willis.
I know him.
Yeah. Excellent project, Avi. Thanks so much for open sourcing it. It seems that existing aggregators like FluentD were far enough from ktranslate goals that it was worth building your own. If time allows, could you please walk us through the decision process?
Sure. So we looked at, I would say, 3 main systems probably a couple years ago when we were really starting to think about this. There's FluentD, there's FluentBits, which I am subtly confused on, except one is faster than the other, but they're different projects from the same company. And then Telegraph that a lot of people use. And the biggest thing that was missing, which is something which, as Mike points out, that people are working on with OpenConfig, is sort of some common sense of semantics. So Telegraph, so none of them, all of them had some abilities. People had done some network things with them, but it wasn't they weren't coming from a rich set of network inputs already. They, in some cases, on the FluentD side, I think there were performance issues when we looked at it, but it was really this translation layer was usually leave it up to the customer. And so the thing that we saw more of our customers using was Telegraph, typically for people looking to get to try to build something on top of Prometheus or Influx for device metrics. And with Telegraph, we talked with them about saying, hey, what about a generic layer for these transformations that you could make into a library? And they just weren't interested in that. Their view was that their customers were happy to all build those transformations manually. Sort of like the network world equivalent is we automate by writing a Python program to do one CLI thing, and then every engineer writes the same thing. That seems like a lot of wasted effort where there's a chance for abstraction. So that was how we thought about it. And then recently, there's been people taking open source ETL platforms like Apache Nifi, or commercial companies like Cribble, or open source companies like Airbyte that's copying Parse's thing, which I forget what it was called. And they don't support a lot of the network primitives, or Apache's in the open, but is Java and not as performant for the levels of traffic that some of our, some of the big network operators run. So if anyone's curious about the other projects out there or the decision tree, feel free to ping me, avi@kentuck.com. And I will introduce you to the labs team.
Okay. Is there anyone else, either remotely, that was the last remote, or coming up to the microphone? Going once, going twice. Sold. Thank you, Avi.
Thank you.